Starting at the top attachment point, I want to be able to install and uninstall the tracker as rapidly as possible. A, because I have to do it a lot for development, but B, in case of a storm, I might have to take it down in a hurry. Eventually this will be hoisted by a pulley or something automated, but for now it's bolted in place. These are 2 stainless steel eye bolts, and they're secured with a nut and a lock washer. T-slot framing has these holes that run through them, but they don't come threaded unless you pay extra to have it done. So I thread them myself, and the process of threading them is called tapping. And it seems like an intimidating thing to do at first, but it feels really enabling once you know how. Briefly, you'll need some cutting fluid and your tap. Add your cutting fluid. This is Tap Magic Industrial Pro. Make sure the tap is lined up straight and start twisting. Once you get a little bit in, you want to go a rotation or 2 forward and then about a quarter turn back. And this back turn lets all the metal scraps out so they don't jam up the tap. I'll speed this up a bit, even though it's hard to talk slowly to sound just right, even at a faster speed. There you go, adult skills. Next we have this top attachment for the pulleys. First we need to remove these carabiners. It's important for these pulleys to be stainless steel so they don't rust. Also, if the trough of the pulley roller isn't deep enough, the rope can get pinched here between the roller and the sidewall. This eye bolt is secured with a washer to span the slot, a lock washer, and a nut. I threaded the hole here so the eye bolt screws directly into the frame. Alright, now moving down the frame we get to the Fairleads. Fairleads help gather our rope so it spools nicely. They also keep the ropes close to the frame so they don't hit the outer casing we'll add eventually. It's important to have something that rolls here so the motors don't have to work harder and the rope doesn't wear out. Turning things around, these custom Fairleads attach to the frame with a screw and a T-nut here. There are plenty of Fairleads you can buy, but they're heavy, expensive, and wouldn't really fit our frame very well anyway. Anyway, they're pretty simple, just 2 rolling pins that are clamped in place by these screws that we unscrew here to disassemble. To make a Fairlead roller, we take 2 sealed bearings, a steel shaft, and an aluminum tube. First we have to file the inner part of the aluminum tubing so the bearing will slide inside a little bit. Then we can squeeze the bearings in place with a vise. Really happy with how well these fit together. I mean, too tight and the bearing could break when we squeeze them in, and too loose and it would all just fall apart. So really cool. Then you can put the steel shaft through the bearings and voila, a roller. Finally, you just insert the steel shaft in here and lock it in place with this screw and T-nut. I need to take a small detour here to talk about jigs. If you don't have a fancy drill press to make accurate holes, you, or at least I, can't really do it reliably by hand, so I made these jigs to guide the drill bit. Links to these 3D model files are in the description. A roll pin in the drill hole protects the 3D printed PETG filament from the drill bit. As with tapping holes, you should always use cutting fluid to drill. I don't think I could do any of this without a 3D printer, just the customization and how fast you can iterate. I've had this Prusa 3S for 5 or 6 years. The Prusa works great, but I needed to get a second printer because when I start printing, of course, that's when the kids want to print and they only want to print when I'm printing. I went with the Bamboo Lab A1 Mini and have loved it. I hop on whenever the kids aren't printing anything. It's fast, no issues, makes beautiful prints. Back to the teardown. This is where the Fairleads connect. I haven't shown this up close yet, but this is a T-nut. It slides along the railing to allow attachments. Specifically, this is an economy T-nut, which I use on parts that won't be supporting a ton of weight. Now we need to go over attaching the rope to the spool of our winch. It sounds simple, but how do you attach it so it doesn't slip and you don't compromise the strength of the shaft? Spoiler alert, I use shaft collars and set screws to give the rope something to grab onto. I protect the rope from all those sharp edges with this T-Rex brute force heavy-duty duct tape. This is super strong. You can't tear or stretch it with your hands like normal duct tape. To make sure the rope doesn't slip over the top of the set screws, I have a zip tie on here. The rope is tied in a Two-Wrap Prusik knot with the loop of the knot going around the set screws. I mean, of course, a Two-Wrap Prusik. I need more tape here to keep the set screws from cutting the rope. And when the set screws are undone, the shaft collars are free to slide around. When I had just one collar and set screw, I tested it out with over 100 pounds, and it did start to slide some. The solution was to score the shaft with a metal scribe. That alone gave it enough friction to stop the slipping, but I added a second shaft collar just to make sure. That was maybe hard to see, so here it is from beginning to end with bigger set screws. First, put the steel collars on the shaft. Score, score, score. Tighten the set screws. Then tie our Two-Wrap Prusik. Cover the set screw threads with tape. Tie a zip tie around it to hold it down. That's a little hard to do with one hand. And finally, wrap some heavy-duty duct tape around everything to protect the rope, and that's it. Next is the enclosure for our worm gear. I learned a hard lesson in an earlier model that ants love getting into nooks and crannies. These ants only had about 30 minutes of access to the LCD, but when I opened it up, it was full of eggs. That can't happen to the gears, or they'll wear out fast. It doesn't have to be waterproof, just bug and dirt proof. After many iterations of tweaking on Tinkercad, printing, and tweaking again, here's the final result. There's still a gap here between the T-slot groove and pillow bearing. I'll need to plug that up with maybe something cottony or tape it up to totally block it off. And there is our spool and worm gear wheel. The pillow bearings hold on to the spool cylinder with set screws. These spool ends are 3D printed flanges that have shaft collars inside of them. Holes in the flanges allow these long set screws to go through both the flange and the collar to grab onto the spool cylinder. I like these steel collars, but they do have this lip on them that keeps them from sliding past the top. I can see why someone would want that to keep them on the end, but I don't. Only takes a second to file those off though. There's our servo and worm gear. Let's take those off. The servo is connected by a shaft adapter to a 6mm D shaft that goes through the worm and 2 bearings. Its cord is soldered to a 3-pin waterproof connector. Now for the servo cradle. It's got gaps there to help dissipate heat. This couples with the enclosure top I showed before. Love that snap sound. Notice there are square nuts in the side columns here to give the screws something to pull on. Let's take out these T-nuts. They need a good tap to get them free once they've been tightened in there. The small silvery T-nuts that were holding the servo cradle in place came from this little kit. They aren't load bearing, so they don't have to be that hefty. Here's another custom-made Fairlead. Speeding up through this next part, as it's similar to what you've already seen. This is a good moment to explain my gear choice. I chose the worm gear because it's really hard to backdrive. In other words, the load itself can't easily move the gear. This is important for our tracker because the gear will mostly be sitting still, and we don't want to waste energy trying to keep it in place. Now let's look at the flange bearing where the panel connects to the frame. Okay, that came out way too easy. Alright, I need your help here, so you need to focus. The flange bearing shifts in its base way too easily if there's any off-axis force. It can't move like that, or the panel won't be held as securely. My hack was to put a large bearing behind it to hold it straight, but that only works if the bearing doesn't move. At first I tried putting a set screw from the side to lock it in place, but it hit the bearing too low and kept sliding underneath it. The strategy I tried here was to press these T-nuts up against it firmly and screw them in. That clearly didn't work. I think what I need to do here is to let the bearing sit lower. That way the set screws can hit more in the middle. So I'll need to redesign the black insert to be thinner and can try again. Anyway, let me know what you think in the comments. We have a magnetic rotary encoder at the base here to sense the east-west rotation of the panel. I know what you're thinking. What about the heat shrink solution from your fancy waterproofing hack video? I still use that in the mag encoder on the panel. That one's a lot more exposed to the elements, so I need something more rugged there. But I was really struggling to get it to fit and align in this tiny space. What I did here instead was to coat it with liquid electrical tape. It's just this thick goopy goop you can paint on electrical surfaces to keep them protected from the elements. Wish I knew about this stuff sooner. I use it all the time now on my soldered joints before I put regular heat shrink over the connection. Now for the bottom attachment point. Again, this needs to allow us to remove the tracker in a hurry. Big changes will be coming to this part soon, but for now we'll just slide it over these screws on the pole. More T-nuts here to hold the bottom attachment point on there. It's really important that the back of the tracker be smooth. We may be hoisting it up in the future and I don't want it to catch on anything. I think it kind of looks like a metal guitar from that angle. To hold the mag encoder cradle in place without cluttering up the back, I printed these sliders that go in the T-slot grooves. They're tightened in place with a square nut and a set screw. The encoder cradle itself has the same slot pattern, so the sliders can lock them right in place. I added an attachment point here to potentially connect an elastic cord to the far end of the panel to keep it from moving in the wind. This bottom 1010, or 1x1 piece of framing, screws into all of our 1030 pieces, securing those. Each of those holes in the 1010 were drilled using the jigs I showed earlier, and the 1030s were tapped as I showed previously. Now to dismantle my solar guitar. Drilling this hole was intimidating at first, but actually pretty simple. Just add cutting fluid to the hole saw and drill away. Alright, not much left to take apart now, so all done. So, all you armchair engineers, or even real ones, any thoughts or suggestions, anything you think won't hold up, please let me know in the comments. A great job or a like is a real shot in the arm, but something like, hey, have you thought about trying it this way? Or you're holding your screwdriver upside down could really change the direction of what we do and save us a lot of time. If you know any other nerds with strong geek tendencies that you think would like the video, please share. The more feedback, the better. To help you with your own projects, I've included links in the description to any parts or tools that we used in each section of the video. Many of those are affiliate links, so if you buy through those, we get a small percentage that would help us keep developing the project. Lastly, we're just getting started on this journey. If you want to come along, hit subscribe and join us as we build something new from the ground up. Okay, thanks for watching. Till next time, bye. Hi, I'm Dante with Dawnward with an update on our suspended solar tracker. So, all you armchair engineers, or even real ones, any thoughts or suggestions? Anything you think won't hold up?
Sorry.
How is that funny? So,
Funny.
it's not funny. So, all you armchair engineers, or even real ones, have any thoughts or suggestions? Have any, sorry.